Take it away.
Hi, my name is Tyler Palino. Good afternoon, and I'm here with the Space Pythons to introduce and demo our project called FraxRay. So it is a AI that can detect fractures in X-ray images. And we created this project because I took a medical class in my high school, so I think it's really cool. And I know that radiologists, which look at X-rays, the main reason they get sued is because they miss a fracture. So we created this project to detect fractures and create a reports for radiologists. So here are some example images of correctly identified X-rays from our earlier models. And then here's the team. So I'm Tyler Palino. I was the front-end developer, and I'm a rising junior at Laguna Beach High School.
I'm Aryan. I'm going to be a junior at Woodinville High School, and I was in the front end team.
Yes.
I'm Stanley, and I'm a senior at Ansabarta High School, and I'm part of the back team.
I'm Noah. I was part of the back end team, and I'm a junior in Monroe High School.
I'm Adrian. I was also part of the back end team, and I'm going to be a junior at Da Vinci High.
I'm Kasra. I'm a junior at Marilama High School, and I was part of the front end team.
Okay, time to show off the project. So I have 4 images to show off. So we'll start with a fractured. So you can see the AI correctly identifies the fracture and says the confidence value along with how many fractures there are. So there's just one in this case. So moving on to, it also can identify images with no fractures. So here you can see there is no fracture and so no confidence value is shown. But for one with multiple fractures, 2 confidence values are shown for each fracture. And it's also able to detect the big fractures where the breaks are farther apart. And then Adrian can talk about the back end and about our data set and AI.
Yeah, so obviously we'd like to have 100% confidence if possible, which technically isn't. But as you can see on the images, it was only about 80% confident, maybe 90% for some of the images. And a lot of that comes down to the time limit and the image limit that we have. So first of all, as long as 3 weeks sounds, a lot of that time is spent learning how to use Python, how to use HTML, how to learn all of these things so that we can actually make the model and the website. Another thing is we only had about 200 images originally for our data set. And this is due to the confidentiality of medical images. We can't exactly find a ton of them because of how confidential they are. With augmentation and pre-processing, we were able to get about 800, 700 images for our training data set. But still, as you heard from a lot of the teams, some of them had over 4,000 images for training their data set. And so on the bottom here, you can see kind of our loss graphs. On the left, it shows the loss. So obviously, we want that to be as low as possible. Loss being the actual prediction, or is the actual value minus our predicted value. And so as that approaches 0, our model gets better and better. And on the right, we can see the precision of our model. MAP stands for mean average precision. So as you can guess, we want that to be as high as possible. And for the future of our project, we wanted to improve some things about our website and our model. First of all, you can only do 1 image at a time right now, which for radiologists isn't going to be super helpful because they can identify it much faster than our model can. So being able to do a ton of images at once would allow us to greatly improve the efficiency. Another thing is being able to integrate directly with hospitals. Having to get the image and then upload that to a separate website in order to identify the fractures in the image is not entirely efficient for the radiologist and would probably prove worse than just identifying it themselves. Another thing is we want to be able to differentiate between fractures. As you can see, the fractures, it only said there was a fracture or there wasn't. We'd like to be able to determine if it's a spiral fracture, a green stick, just any different kinds of those. And then finally, we want to be able to identify less noticeable fractures. As I'm sure you all could tell, those fractures were pretty easy to identify and definitely wouldn't be hard for a radiologist to see. However, some fractures aren't as obvious. And so it would be a lot easier for them if we were able to identify those minute little details that could show this. Thank you for listening. Do you guys have any questions?